Welcome back, guys, to the challenge lab of Module 9 about creating a scalable and highly available environment for the cafe. Now, the starting architecture for this lab is going to be a NAT gateway with cafe application server in the private subnet 1 with an AMI that we are going to use and pass to the autoscaler. And the target is to create a load balancer and autoscaling group to scale the cafe application that speaks as well with a primary DB instance. So the first task in task 1, we want to inspect the environment that we have. So we need to go and access AWS. Now AWS is ready now. So let us go and see the VPC, what we have in our VPC. So you can see there is a VPC called Lab VPC. In the subnet, we can see in the Lab VPC, we have two public subnets, 1 and 2, and we have 4 private subnets as well. And then we have a route table for the Lab VPC. And those Lab VPC route table, there is private route table 1, private route table 3, private route table 2, and there is public route table 2 and 1, and there is private route table 4. Later on, we will deal with those route table in order to enable multi-AZ deployment and highly available architecture. So we want to see now what we can do about these tasks in step by step. You could carry on now and answer the question from 1 to 6 in the multiple choice questions in the details tab of this lab. And the first thing I'm going to do is task 2, where I will create a NAT gateway. So I'm going to go to the NAT gateway and create a new NAT gateway. Now this is going to be in the public subnet as specified in step number 8. For the second availability zone, so this is public subnet 1 is in US East 1A. So I'm going to select US East 1B, which is public subnet 2, and will be an elastic IP address, and create a new NAT gateway. We want to configure the network in step number 9 to send the traffic to this basically public subnet. So let us look to public route table 2 and see if this is associated with public subnet 2. Now in the route, I could see that this is going to the internet gateway, but what I want is to link private subnet 2, and maybe it's much better if we go back to the architecture. Now, public subnet 2 is going to send the traffic from the NAT gateway to private subnet 2 and the private subnet 4. So basically, in step number 8, we want to send internet inbound traffic from an instance in a private subnet 2 to the NAT gateway. So let us look to private route table 2. And we can see this is the private subnet 2. We are going to go to the routes, edit, add any IP to go to the NAT gateway, which I just created. And we can see here the NAT gateway, I have both of them. So I will open the VPC in a new tab here, right click, open a new tab. And let me go and test and get the NAT gateway that I just created, the one with available. I want to get the NAT gateway ID. I could basically save this in a text editor, and then I go back and I select 6E9, and this is basically the one I choose. Save changes, and now that NAT gateway is going to be taking NAT gateway is taking the internet connection inbound and send it to the private subnet, as you can see here in the subnet association. The next step is to go and create a bastion host. So we are going to go to the EC2. So let me open EC2 in this new tab. And we will launch an EC2 with Amazon Linux 2 AMI with T2 Micro. and this instance will be placed on the lab VPC, and I will put it in the public subnet 2. I will enable IP address, and now I will proceed to add storage. Add tag, I will call this machine Bastion host, and then configure security group. We want to call this Bastion security group, allow SSH from my IP, and this is going to be my IP address here, review, launch, and this will take the Vocarium key. So in task number 4, guys, we need to create a launch template. So if you notice, there is a new AMI created for us in the lab console, and there is a new EC2 here. There is a new EC2. After we create this Bastion host, there is a Cafe Web app server, and we want to create a launch template. So let's go and just do that. In the launch template, we go and create a launch template. We will call this a launch template. So Cafe launch template. There is no specific name specified. Now the template should use an AMI, and we will look for the cafe. In this case, the Cafe Web Server image. The instance type is going to be T2 micro, and we need to create a new key pair. So let me call this cafe key, and this will create a PIM file for me as well, and that cafe is now downloaded to my download folder. So if I need to access the machine, and this template as well, it will be taking the resource a new security group, which is the cafe security group. That's the cafe security group that we are going to use. And for the resources tag, we need to add name, and we call this web, small letter, web server. And then we need to keep the resource tab in instances, and in the advanced details, we need to have a cafe role. I think this is what we need so far for this template, and then create a launch template. Now we need to go into that launch template, and we can basically use it to create an auto-scaling group from action. We will call this group auto cafe auto. Now this is the launch template. That's the first default one. Next, and this will be in the lab VPC, and we want it to be in the private subnet of the first availability zone. That's the first availability zone, and then in the private EC2 in the second availability zone, which is private subnet 2. And you can also verify or roll back to your diagram, and you could see the application server need to be in private subnet 1 and the private subnet 2. And there is, in task number 5, there is, next we need to go and have no load balancer actually in this. We want to specify the desired capacity to be 2, the minimum to be 2, and the maximum will be 6. And there will be a target scaling policy with the average CPU 60. The target value is 25, sorry, and the instance needs 60 seconds to warm up. Click next, and then add tag. We can just add tag to make sure that these are created by the instances. Lab auto. Next, and then create. Now, once we create the auto-scaling group, we are supposed to see there is a new EC2 instances will be added to our instance. You can see now the auto-scaling group is updating the capacity. Now we need to create a load balancer. So we keep the auto-scaling group to work out, and then we create a load balancer. It's going to be an application load balancer. It will be called Web ALB, internet facing. It will be in lab VPC, and this will operate in public subnet 1 and public subnet 2. Now, how I know that? From the diagram. You could see the web application is an internet-facing web application load balancer operating in public subnet 1 and public subnet 2, where each one of those public subnet has its own NAT gateway. Now, I believe we should be able to finish the creation of the load balancer. And we need to create a new security group. We call this Web ALB security group. It's a good name. Allow access to the Web ALB, and make sure to select the lab VPC, add inbound rule, and this will be an HTTP from anywhere. And just create a security group. Go back to the load balancer creation and refresh, and you should be able to see the Web ALB. Remove the default. Don't forget that, guys. Now we don't have a target group, so we need to go and create a target group with instance, and this is will be web a group, and this is again will be lab VPC, and it will be next. I think there is no spaces allowed, and then next, and then create a target group. So we can see now the load balancer should get the new target group, and then we create the load balancer. We need to wait for the load balancer to be available. So that's the DNS name of the load balancer. Open it in a new tab and paste it. Now we can't see any service yet in the Web ALB, which is normal because we haven't yet registered any healthy target with the Web ALB target group. Now you could go to the EC2, and from your EC2s, you could see there must be a new instances created for us, which are the lab auto. These are still initializing. Another thing you could do to make sure in the lab auto, you can basically edit, and now you link the lab auto with your load balancer. And you select the web group ALB, similar to what we did in the guided lab. Let us make this 100 seconds or even 90 seconds will be good, just to test the lab and basically get more update from the load balancer with the health check very quickly. Now go back to your load balancer and see if we can make any registration with the target group. So let's go to the target group and see if we can register any healthy target. So the target registration in progress, which means we need to wait for a few seconds until we can see. So we'll need to keep an eye on this page and we can carry on with the rest of the lab. So task 4, we want to test the Cafe web application. So to test the Cafe web application, we need to go and visit the domain name service or the domain name system of the load balancer, which already did, but we are still waiting for those guys to be registered. You could also check the auto scaling from here. So let's open a new tab and check the auto scaling and make sure that the auto scaling is doing some activity with successful state, which means it's creating. Let us go back and refresh the load balancer. And maybe a few check before we carry on. Go to the security group and check the Cafe security group, which edit. And here you can make it this receive only the security group from the web ELB. You can delete and add a new one, HTTP. And this is what we call the security group or chaining of security group. Which is something very important to do. It seems to be we are not authorized to do this action. Let me go back, cancel, inbound. So this security group created by the CloudFormation, I believe we cannot edit. And now let us go back to our web ALB and see if we are getting, yeah, we can receive some web application traffic now, and the auto scaling, it seems to be creating all the EC2s that we need, which are the desired capacity, which are 2. In task number 8, we want to test the automatic scaling under load balancing. So we will need, in this task, we will test whether the Cafe application scale out automatically by using SSH. We need to add both security key, the labs user, and the Cafe key, which we use to create those EC2 machines in the private cloud. So we need to do chmod and 400 Cafe key. Now SSH minus add minus K and labs user .pem file, and the same command SSH minus add. If you are using Windows, going to be using the P agent that works with POTI. If you are using Linux and Mac, this is how you do it. And this will be the cafe key.pem file. Now I should be able to access the bastion host without passing the key pair name. You could also make sure it is working, or you should actually, basically, you're supposed to add SSH minus A EC2 user at the public IP address of the bastion host. Now, let us go to one of those Cafe or Lab Auto, which we can see they have an IP address here. Now, if you check before we can be able to test those EC2, they are working with us. We need to make sure that the Cafe security group have a port open for 22. Now, if you go back to the lab instruction, they said we need to modify the Cafe security group to allow SSH. So we need to do that first, edit, and add a role. And this is going to be SSH. And from this custom, we need to make sure it's only able to be accessed by the Cafe security or by the bastion host security group. And save. I managed to connect, which we'll do for today. Now we need to install this tool, which is a stress testing tool. and we will run that test here on the private instance with CPU core, and basically we are going to do as well a timeout of 600 seconds. So we need to wait for this to be installed, and then we run this command, which is to create basically a CPU stress, which will trigger the load balancer. So we could go to the load balancer in the activity or in the monitoring, and we'll start to see now that the CPU of the instances start to increase. You could also go to the instance itself, lab auto, monitoring, and you will be able to start seeing the CPU utilization getting more data. And you will see as well that there is more application will happen. Now, to help the autoscaler create more machines, I will stop the Cafe Web app server. This is basically will create more traffic. Now we will verify the lab that the autoscaling is working as expected, and you can see the load balancer is working as expected, and it will be all for this lab. And once you finish, you can submit this lab, and I will see you in the next one. Thank you.